differentiation of the derivative?
Yes, awesome. So let's say x minus 2 over 2x plus 1. So there is only one definition of the derivative, and that is those two powerful concepts put together. The concept of the limit as age approaches 0, and the concept of the difference quotient, f of x plus h minus f of x divided by h. This is the only definition of the derivative. Everything else is differentiation rules and other things. So this is very clear, but in order to find this, I need to replace x everywhere by x plus h. It's not a big deal because this is just algebra, right? So that's my page 2. Okay, so we have f prime. So you have to start by writing f prime. You have to continue with writing the limit as h approaches 0. Then you have to write the difference quotient. You have to replace this. So this is x plus h minus 2 over 2x plus 2h plus 1 minus x minus 2 over 2x plus 1 divided by h. Notice that I already distributed. So I have x is x plus h. 2 times x is 2x. 2 times h is 2h plus 1. Now, can anyone tell us what will be the next step? What do we need to do next? Do not forget the limit operator. What do I need to find next? H is always h over 1. We are preparing it for flipping it. So, can anyone tell us what is the next step?
Cross multiply.
You mean finding the least common denominator. I agree. What is the least common denominator? I agree. It's a different way of saying it.
2x plus 1.
Okay. Do we all agree with this as being the least common denominator? Are we getting stuck on an algebra? I hope not.
Sorry, what was the question?
We need to find the least common denominator. We cannot continue. I have to perform these operations, and if I don't have the least common denominator, I'm stuck. Anyone, please?
X minus 2.
We're talking about the least common denominator.
Minus 2x plus 2h plus 1.
Thank you very much. So these two denominators have nothing in common. Because they have nothing in common, both factors have to be in the least common denominator. Good. So this one needs to be multiplied by 2x plus 1. And this one has to be multiplied by 2x plus 2h plus 1. So, watch me run out of room. I always do. So, 2x times x, 2x squared. 2x times h, 2xh. 2x times negative 2 minus 4x. 1 times x plus h minus 2. Negative x times these minus 2x squared minus 2xh and minus x. Now negative times negative is positive 2. That has to be distributed to these three terms. I'm going to write it at the top because I ran out of room, of course. So plus 4x plus 4h and plus 2. Good. So we have the least common denominator and we have the numerator. What has to happen next? Before I continue, I just want to make sure that I'm on the right track. So what has to happen now?
Some factor that does not have to cancel.
All without h must go away. If they have h and they're still there, then something is wrong. All terms with all terms without h must go away. So 2x squared with negative 2x squared. 2xh with negative 2xh. Even some terms with h, fine. But all terms without h must go away. Good. Let's see. Positive 2 with negative 2. Positive 4x with negative 4x. Positive x with negative x. So from all these terms, I'm left with positive h and positive 4h. That's it. There is nothing else at the top. So I have limits as h approaches 0. And 4 plus 1 is 5h over this. 2x plus 1, 2x plus 2h plus 1. Now I can flip 1 over h. What has to happen next? Remember, the limit operator has to stay. We have not applied it yet. So what has to happen next? Anyone, please? Anyone, please?
Are we multiplying the denominator by h?
So I have a fraction divided by another fraction. I copy the fraction from the top and I flip the fraction from the denominator. That's the rule for dividing fractions. Now what has to happen? Because if it doesn't happen, I can continue. I know Donna and Carmen are with me, and Garby. Anyone else would like to say anything? Well, obviously the h has to go away, and that's the second step. And now I can apply the limit. This is the only term that goes away because h approaches 0. So it's 5 divided by 2x plus 1 squared. Okay, next question. Anything else you would like to review? Is this okay? Any questions on this problem? Anyone? Any questions on this problem?
I don't have any questions. I think I'll just have to practice it more on my own.
Okay.
So maybe, I'm not sure if this is going to be on the test, but it's finding the average rate of change of a function between points.
Yes, this is just algebra. So if I have, let's say, f of x equals x to the third, and I have 1, 1 and 2, 8, then the average rate of change is 8 minus 1 over 2 minus 1. So this is 7. We review the average rate of change because we wanted to discuss the difference quotient. So we can put it inside the limit and find the derivative. But this is just algebra. The average rate of change between 2 points is just the slope of the line passing through those points.
Thank you.
Thank you. Now, if you want the average value of a function on a given interval, it's a different story. If you want the rate of change, it's a different story. But if you only want the average rate of change, then it's just algebra. It's the slope of the line. Good questions. Anything else?
Can we do a problem for finding relative extrema?
Yes, absolutely. For one variable functions with one variable, or functions with more than one variable.
Functions with more than one variable.
Can you find the problem for us? So last time, I don't know if you were here or not, but that it doesn't matter. We had one at the beginning of the class, and we had another one at the end of the class. But if you have a question that you would like us to work on, let's do it.
I don't really have a particular one. I was just looking at the test 2 problem, and I kind of got confused on it.
But that's not in test 2, that's in test 3. That's not in test 2, it's in test 3. Are you talking about the absolute max min on a closed interval? Are you looking at test 2 or test 3? Are you sure? Because
I was looking at test 2, it's like the first problem.
okay, so can you dictate the problem? But that's not a multivariable. It has only one variable, not two variables. So if you're looking at test 2, you're looking at something like this, not at something like this.
Yeah, I'm looking at the first one.
Sure. Okay, we're ready. If you want to give us the function. Is it on a closed interval?
There's no closed interval.
Okay.
It says 0.00259 t squared minus
There are 2 zeros after the decimal point or 3?
just 2.
Okay, perfect.
0.457 t
457t.
plus 36.237.
Okay, so we want to find the relative extrema for this.
Yes.
Okay, so all we have to do is find f prime of t and set it equal to 0, because it can never be undefined for a polynomial function. So f prime of t, when I multiply this by 2, I get 8, 1, 5, 0.00t minus 0.457. And when I set this equal to 0, I have t equals 0.457 over 0.00518. I have no idea what that is, but I can 557 divided by 0.00518. So I got 88.22. So t equals 88.22. So at this point, I create the table with f prime of t and f of t. I put 88.22, I put 0 here. I have to plug in the function 88.22 to get this number. We'll do that in a moment. But I have to study the sign left and right. So looking at the derivative, if I plug in 0, which is on this side, I get negative. And if I plug in 10,000, I get positive. So this has to be the relative and absolute minimum. What is it? I don't know. I have to plug it in the function. So I have the calculator ready. So we're going to do that. I'm going to share my screen. And here it is. You know me, I like to see the function. And the function was 0.00. Again, this is just algebra. There is nothing to it in the sense that we just have to plug it in. Minus 0.457x and plus 36.237. And when I plug in 88.22, I get the maximum, 16.08. Very good. Is this okay?
Yeah, I understand it better now.
Good. Awesome. Next question. Anything else that you would like to continue with? Anything? Anything else?
Can I ask about?
Yes.
I don't remember. I know it was in test 3. I think it was 6.3. dy over dx equals 2y. I just don't remember how to do this. Equals 2y.
Okay, so this is chapter 5, and this is section 5.7, and this is differential equations. We have to first multiply both sides by dx, so dy equals 2y dx.
Okay.
Then we divide by y, because we have to separate the variables, dy with y on one side and x with dx on the other. And now we
Is
integrate.
it 1 over y dy, technically?
No, dy is in the numerator. I cannot bring it to the denominator, right?
Or I thought we're seeing it as 1 over y.
Yes, yes, yes. We have to look at it always like that. Yes. So here we write it.
Okay.
We write it condensed, but basically this is what it means. Yes.
Okay, now I remember. Okay, thank you.
So then the natural log of the absolute value y equals 2x plus a constant c. And this is the difficult part here, because remember we have to change the logarithmic equation into an exponential equation. E to this equals the absolute value of y. So we have to write it as e to 2x times e to c, because we are going to replace this by another c. You can call it c1, you can call it c0, whatever you want to call it. It doesn't matter. It's a constant. So then we will have y equals plus or minus this constant times e to 2x. If you want to say, but this was c, why do you use c? Okay, use c0. If you don't want to use the same notation, that's fine.
Okay, thank you. I just, for some reason, got confused. And
It's a
didn't
lot.
think
It's a
why-
lot.
why-
It's a lot. Remember, I sympathize with my students always. We had 15 weeks. We had 15 weeks, and we went from R.1 through 6.4. A lot of topics, a lot. So I know it's, especially now at the end, it gets confusing. I know that.
This topic isn't that hard. It's just we're getting
It-
to realize that you can multiply.
This topic is the most difficult in the entire course. It's very hard. In my opinion, this is a hard topic. Yes, this was a decent problem, not too difficult, but this is the most difficult part of the course. 5.7. That's it. That's my opinion, though. Because first of all, it has some algebra, then calculus, and then it could be potentially tons of algebra again. So I think it's one of the most difficult, but I'm glad that you don't find it difficult. That's awesome. Good. Next question.
There was a question on test 3
Yes.
regarding finding the domain
Yes,
and then putting it in some type of
yes.
I forgot what was the word.
It's called